new juicy stuff. So, but we'll get started. How do we add or subtract monomials? They have to be like terms. Right, so we'll start really basic and then build up. There will be new stuff today, I promise. Okay, multiplying, distributive law, right? 5x times 6x, 30x squared minus 35x. Okay, binomial is just an extension of distributive law. So you can actually take a binomial times a binomial and write it the 2x times the 4x plus 1, and then the negative 3 times the 4x plus 1. Or another name for that is just go straight to FOIL. Because what are we doing? We're taking the 2x and multiplying it by both the 4x and the 1. 4x and the 1. And then we're taking the negative 3 and multiplying it by the 4x and the 1. Right? Remember that? We're good? Should we work this one out? Keep going? Okay. Keep going. And we can extend that, right? We can extend FOIL. Just a quick review. If we have an exponent, a binomial squared, what do we have to do with that? Careful with the word double, because double implies multiply by 2, but I know what you're thinking. It's multiplying by itself. Yeah, that's multiplying it by itself. I know that's doubling it sounds like. I know what you meant, but be careful. Doubling it means doubling it, timesing by 2. And then we'd have to use, again, FOIL or distributive law. How many things can we multiply together at a time? 2. Like, can I take this, would I take this 2 and multiply it into all of these? No, big mistake, right? We can only multiply 2 things at a time. So we'd start by distributing first the 2 in, and then we can FOIL, right? Again, also with the subtraction, when we FOIL this guy out, you're going to want to keep the brackets and then bring the negative in. Wish I was wearing a belt. Okay, so that's just some quick review of some stuff. You'll have some homework questions on that, and the solutions are online if you need to look at them. Okay? And these notes are online, the complete notes, if you wanted to take them home and finish off some of the notes today. They're going to be on the site. Okay? All right. Factoring. This is really good stuff. Factoring is so important. You probably discovered that last year in 20-1. Factoring, factoring, factoring. Okay, so in factoring, basically, we're going to add brackets. We want to create multiplication, right? Change to multiplication. Change to multiplication. So we're going to, basically, we're forming a product. Oh, that was probably even better to write. Oh, well. We're forming a product. We're going to add brackets, something times something. The first thing we always have to check, I don't know if you remember back in grade 10 when I had that pink crown, right? The first thing we have to do, GCF, right? Always check for greatest common factor first. Maybe you don't remember, okay? Still have it, you know. Still have it. That was a really long time ago. Okay, so don't forget to GCF if you can. You must. You want to do that first. And then, of course, we looked at difference of squares. Remember that? Difference of squares, what makes something a difference of squares? There's 3 conditions. It's separated by a minus. You can square root both terms, and it's a binomial. Right, 2 terms. And then you can factor it. This is what's new today, and that's where I kind of want to spend some time, is there is a formula for difference or sum of cubes. This, in the past, I made people memorize it. You're welcome. It's on your formula sheet. I don't have one with me. So if you're on your formula sheet, you should be able to find sum and difference of cubes. Is it there? Yeah. Where is it? Bottom of the back? Sorry, if you need to hole punch it. Yeah, there's actually another formula sheet you're going to get, but that's for integration. You don't need it till the end of the year, so I'm not going to give it to you. Okay, you found it? So one thing you should know, it's proven that this formula, this trinomial is never going to be factorable. Okay, it would be if it was a 2ab, but it's not. So this is the fully factored form. This formula is to make it in fully factored form. It's for difference in sum of cubes. So of course you have to have a binomial separated by a plus or a minus, because there's a summation and a difference formula. And you have to be able to cube root both of them. Now here's something that's a little bit different. In calculus, you can have radicals in factored form. So for example, you can have a difference of squares. If you have x squared minus 5, that factors to x minus root 5 times x plus root 5. Okay? So we do use radicals in factored form in higher level mathematics. Okay? Because that will tell me my root now, right? Plus or minus root 5 are my roots, which you could figure out just from that too. But so if you see that in your homework in the solutions, you might come across that. With a difference of cubes, it's really simple. We just have to have the formula, right? And we have to figure out what our a and b would be. So what would my a be? X. It was x cubed and minus, what was cubed here? 4y would be my b. Okay, so changing it into a cubed minus b cubed. And then we plug it into our formula. So our minus, you'll notice, is still a minus in the first, a minus b. And then the difference here is it's plus a squared plus ab plus b squared. So you might end up memorizing it. I don't know. Okay, so a minus b, so it becomes x minus 4y times a squared becomes x squared plus a times b, 4xy, and then plus b squared, so 4y squared becomes 16y squared. Yeah, easy? It's really just plugging it into a formula. Right. Do you want to try the next one on your own? Are you feeling brave? Why not? That's saying, can you try it on your own? So you might want to change this into something cubed plus something cubed, so you can see what your a and b was. Knowing your perfect cubes will help. And this trinomial won't be factorable. You get the same thing? Yes, hopefully. So it'd have to be 2x, that's cubed. And this would have to be 3y squared. Remember, power to a power makes 2 times 3 or 6. And that's just using the summation formula, because this was a plus. So that's a new thing you have to look for when factoring now. Add that to your repertoire. Kind of a big formula sheet, you'll notice. So we'll have to get comfortable with it. All right, so those are fun. That's something new for today. The rest is review. Good. Let's go on. Grouping. So it's when we have 4 terms, polynomial with 4 terms. Group the first 2, group the second 2, pull out the common difference. And if these brackets are the same, we factor that out. And we use that method, or decomposition we call it, for complex trinomials. We use this grouping method. An example down below is a simple trinomial. Hopefully you're really good with these. I need you to be really good at this. If you're not strong at factoring, you need to get strong at factoring. Really practice the homework, okay? So simple trinomial, what makes something simple? A equals 1. That makes a simple trinomial. And I know it's been a while since you guys seen math, so I do recognize that too. So that's a simple one. Remember, 2 numbers that multiply to the last and add to the middle. So it's sum to 2 and product of -15, so 5 and -3. And then there's decomposition. So complex trinomials, when there's not a 1 in front of x squared. Remember, the first thing we check for is always, before we do anything, when factoring, we check for greatest common factor. If we have a complex trinomial, we need 2 numbers that multiply to first times last. So 3 times 10, or 30, and it still adds to the middle. When we get those 2 numbers, we can't go straight to factored form. Remember, we replace the middle term. We are unfactoring. We are uncollecting like terms because we're going backwards of distributive law. Like if we were to FOIL this, right, this is using distributive law, or FOIL technically. And then, again, distributive law. And then we collect like terms. So when we're using decomposition, we're working backwards. We're uncollecting like terms is what we're doing. And now that it's 4, we use grouping. So we group the first 2 together and the second 2 together, factor out the GCF. The bracket should be the same. And 3x minus 2 and x minus 5. I feel like I have blank stares. Do we need to go through a couple examples? Okay, I think I have some down below. Let me look at my notes. Yeah, we're good. So we'll go through a couple examples. Okay, and there's our summary. So let's look at an example here. First thing we ask ourselves, is there a GCF? 10 and x. Okay, I'm not going to write divide by 10x anymore, because we're going to, just get good at skipping those little things. I didn't encourage you to do that when you're in grade 10, but now I'm saying, yeah, sometimes it's good to skip steps. Skip some of those steps. Okay, all right, so 80xy cubed divided by 10x. 8y cubed plus z to the 6. Are we done? No, yay, you noticed, some of you. What do we have? A sum of cubes. A sum of cubes. So we have what cubed plus what cubed? 2y cubed plus z squared. So we have to use our formula. Do you remember the formula? It's a plus b times a squared minus ab plus b squared for a sum of cubes. Okay, so we have 10 times, so a plus b, 2y plus z squared, yeah, thank you. I need your help sometimes, guys, I'm not gonna lie. Silly mistakes, those are what gets you always, hey? And then a squared, 4y squared, minus a times b, so 2yz squared, plus b squared, so z to the 4. Cool. Want to try the next one on your own, or no? So what do we have here? How many terms? 4. And if we have 4, we use grouping. Okay, so we check first, is there going to be a common factor in each group? Just one, right? So what we can do is rearrange it. So let's try putting x squared y plus 6x squared together. And let's put the minus 9y minus 54 together. Let's try rearranging it and see if that leads us to now having a common factor in each group. Right, we're grouping the first two, grouping the second two. What's the common factor in the first two now? X squared, and we're left with y plus 6. We can do, oh, I think this is going to work. What's our GCF here? Negative 9. Remember, if the first number is negative, we factor out that negative. Y plus 6. And so our answer, oh, we're not done though. We're left with x squared minus 9 times y plus 6. Does anyone see where we can go from here? Close, not perfect. Difference of squares. Difference of squares. X plus 3 times x minus 3. Y plus 6. That was fun. Woohoo! All right, one more. The homework questions are a little hard, I will say. There's some challenging ones in there. Okay, but this one, let's look at this. Is there a GCF? No, 7's prime, and 3 doesn't go into 7, and 3's prime. So no deal. Simple or complex? Complex. So we need two numbers that multiply to negative 60. Be careful of that sign. And adds to the middle of negative 7. All right. Should we make a factor tree, or can we think of this? Factor tree it is. 2 and 30, 3 and 20. You getting there? No. 4, no. 5 does, right? 5 and 12. 5 and negative 12. You can use your graphing calculators for your homework, but not for your tests. Yeah, but I recommend you actually get used to your scientific, because if you're so used to your graphing calculator and you don't practice before your test, you're going to be like, how do I use this thing? During a test is like kind of an anxiety creator. So, anyways, what do we do with these two numbers? Put them in the middle. Remember to keep the same variable of your original middle term. So it will be a squared plus 5a squared minus 12a squared minus 20. Then we group the first two and group the second two. So what do we have in common in the first two? A squared. Yeah, you can. It doesn't matter which way. You'll get the same answer. You know why I did this? I guess the other way you don't have a negative, hey? Plus 5. And then minus, what can we divide those two by if you did it this way? Negative 4. So 3a squared plus 5. So then we're left with a squared minus 4 times 3a squared minus 5. Are we done? Thank you. Difference of squares. Oh, thank you. There you go. Okay, so that concludes the first part of the lesson, right? Is there more? That's it. So I'm going to show you your homework now. So I'm just going to stop the video.